Hi guys, welcome to day 3 of AMDM. You should have just gotten done with warm-up number 1, which I'm about to go over the answers to, and then we're going to get into our first set of notes, which is estimating crowd spaces, notes unit 1.1. Let's go over the answers to warm-up 1. The first question is how many feet are in 3 yards? So one way of doing it is to ask yourself, well, what do I know about feet in yards? And I know that there are 3 feet in 1 yard. And then when you were in coordinate algebra, if you were here, we would set up these charts and we would say we have 3 yards and we want to convert it to feet. And so we want the unit of yards to cancel out. So I'm going to put 1 yard on the bottom so that the unit of yards cross cancels, and then 3 feet will go on top. So now that I just have the unit feet left, I'm going to multiply across, and I end up with 9 feet over 1, which is just 9 feet. So 3 yards is 9 feet. The next question is asking how many inches are in 5,280 feet. So again, ask yourself, what do I know about feet and inches? I know there are 12 inches in 1 foot. So again, I'm going to set up my chart, and I've got feet on top, so I need 1 foot to go on bottom, and then the 12 inches to go on top, so that I cross cancel out the feet and I'm just left with inches, and then I'm going to multiply across and I'm left with 63,360 inches over 1. So that is your final answer. Make sure you are including your units in your answers. All right. Number 3, it says find the area of a rectangle that is 7 yards by 10.8 yards. So before you do any calculation, it's very important that your dimensions are in the same unit. So in here, one side is 7 yards and the other side is 10.8 yards. So since the units are the same, we can go ahead and calculate the area. So area of a rectangle, sometimes people say it's base times height. Other people say it's length times width. Same thing. No matter what, you're going to take the 2 dimensions and you're going to multiply them together. So the area, 7 times 10.8 is 75.6. And because we multiplied yard times yard is yards squared. So that is your final answer for number 3. All right, number 4 is find the area of a rectangle that is 4 feet by 60 inches. So again, you have to make sure before multiplying that your units are in the same measurement. So they aren't. One's in feet and one's in inches. So you have to decide which to convert. Well, this was a multiple choice question, and all of the answer choices were in feet. So we need to take 60 inches and we need to convert it to feet. So above, we said 12 inches equals 1 foot. So here, I'm going to this time put 12 inches on the bottom because I want the unit inches to cross cancel and 1 foot on top. So I'm going to have multiply across still. So I got 60 on top and 12 on bottom. So I'm going to reduce this fraction. 60 over 12 is 5 feet. So now I have both of my dimensions in feet. One side is 4, the other side is 5 feet. Now I can find the area by multiplying the length times the width, or if you call it base times height, to get 20 feet squared. All right. Then we had some proportion problems that we had to solve. You have 2/5 is equal to 8 over x. So because you have a fraction is equal to a fraction, remember you are going to cross multiply or butterfly. So 5 times 8 is going to give me 40, and then 2 is equal to 2 times x, which is 2x. And then I just need to divide both sides by 2, and x is equal to 20. All right, the next problem is we have 3/7 is equal to 5 over 2m. So again, we're going to cross multiply. 7 times 5 is 35, and then we're going to multiply the other diagonal to get 3 times 2m is 6m. So then we're going to divide by 6 on both sides. This time it doesn't go into it evenly. M is equal to 5.83 repeating, but if you look back at the instructions, it says round to the 10th place. So remember rounding, this is your 8 is in the 10th place, which means we're going to look at the number in the hundredths place to determine what we're going to do to the 8. So 5 or more, let it score. 4 or less, let it rest. So since 3 is less than 4, we're going to let that 8 rest at a 8. So M is equal to 5.8. All right, so for today, Unit 1.1 notes is estimating crowd spaces. And this is really important when planning things like parades or even when the administrators are preparing for evacuation drills, making sure that the spaces that they've located for us are enough size that all the students that they want to fit can fit in that area. Also, with social distancing, it's been a big factor of how many people they can allow into the wave pool at Lake Lanier. So we're going to take a look at this activity, and we can't quite set it up anymore like I used to in the classroom, but we'll work it through together, and hopefully this will help. All right, so I would normally have marked off a 5 by 5 foot square and to see how many people can fit into it. And in the past, we've had about 11 students able to fit into this 5 by 5 foot square. So if you can imagine, I used to tape off a 5 foot by 5 foot square, and then I would have volunteers come and we would see how many could comfortably fit. Now sometimes the class liked each other and they got super close. Other times the class was like, I'm not sure about this, and they were a little further apart. But I would say most of the time we were able to put 11 senior students in a 5 by 5 foot square. All right, so then part B says divide the area of the square. So if I've got a 5 by 5 foot square, what's the area of the square? 5 times 5, 25 feet squared. And I need to divide that number by the number of people that were able to fit inside the square. So I just told you it was about 11 students. So we're going to divide those two numbers, and you're going to get about 2.3, okay? And it says, what does this ratio mean? Well, we have feet squared on top and students in the denominator. So this 2.3 means that we have 2.3 square feet per student. That's how much one student would take up. So this number is telling us how much space one student takes up. All right, so then in part C it says use the ratio to estimate the size of a crowd that is 10 feet deep on both sides of a street for a mile and filled with people. So this is all pre-COVID-19, so we're going to, here's our street. I guess we would have two lines because the median in the middle of the road. And these are our sidewalks. Each sidewalk is 10 feet deep, and they are 1 mile long. All right, so before we get into anything, what we need to do is to figure out the area of both of the sidewalks. So that's going into the warm-up problem that we just did. We have pretty much rectangles that are 10 feet by 1 mile long, and we've got 2 of them. So remember what I said, before you do any multiplying, you need to make sure that both of your units are in, both of your dimensions are in the same unit. So who knows information about feet and miles? Well, if you said there are 5,280 feet in 1 mile, you're right, there is. So I'm going to convert everything to feet, and I say that because we've already have what one person takes up. One person takes up 2.3 square feet. So that's why I'm going to convert this to feet so that all of my units are in feet for this problem. All right, so I'm going to do area is the length, so 5,280 feet times the width, 10. And the important thing here is that how many sidewalks do we have? 2. So whatever the area of one is, I need to double it so that I get the area of both sidewalks. So that's going to give me 105,600 square feet of sidewalk that we're going to have. And we need to set up a proportion. So if one person takes up 2.3 square feet, how many are we going to be able to fit into 105,600 square feet? So to do this, what we're going to do is, just like before, we took the area of the square and divided by how many students could fit into that square. Now we're going to take the area of the sidewalks and we're going to divide it by 1 student. So we've got 105,600 square feet, and I'm going to divide it into what 1 student takes up. And that's going to give us about 45,913 students or people that can fit on both of our sidewalks. All right. The next question is saying one rule of thumb for estimating crowds and each person occupies, is that each person occupies 2.5 square feet. Use the rule to estimate the size of the crowd in question 1. So for parts A, B, and C, what we did is we set up an experiment. We taped off an area, we figured out how many people could fit in that area comfortably, and then we took that number and divided it into our entire space. Now, there's this rule of thumb that an average person takes up 2.5 square feet. So instead of using the 2.3 that we used in the last problem and with our experiment, now we're going to take the area of both of the sidewalks, and instead of dividing it by the number that we found out using our experiment, we're going to divide it by the rule of thumb that a person typically takes up 2.5 square feet. And when we divide those numbers, we're going to get 42,240 people or students. Now I would like you to pause the video, try question 3, and then come back and play the video to find the answers out. All right, so for question 3, it says a football field is 360 feet long and 160 feet wide. So it's always a good idea to draw a little example of what's going on, okay? The principal is making an evacuation plan for the school. How many students can the principal expect to fit on the football field in an emergency? Use part A and B to come up with estimates. All right, so the first thing is that the principal, so this is our football field. And then it says that the principal taped off a 10 by 10 foot square. So now we've got this other square, and he was able to fit 25 people comfortably in it. So using this information, how many people can fit into the football field? So just like before, what we're going to first need to figure out is how much one person takes up. So to do that, that's the area of the square, which what is 10 times 10? 100, over the number of people that can fit in the square, which was 24. So each person takes up about 4.2 square feet per person. Okay, so now that we know how much one person takes up, now we need to go back and figure out the area of the field. So the area of the field is going to be 360 times 160, which gives us 57,600, and we're going to divide that by how much one person takes up, which now our one person average is 4.2. So let's take this over here, and we need to divide 57,600 by 4.2, and we're going to round to the nearest whole person. So we have 13,714 people, and that's our final answer. You always want to round up to the next person. Can't have a half or a quarter of a person. All right, the next problem is saying that using the rule of thumb that one person takes up 2.5 feet, how many people can fit on the football field? So we already know, going back, we already know what one person takes up in this problem. One person takes up 2.5 square feet. So that eliminates all that we did in green in part A, and we can just jump straight to what we did over here in pink. So now we're going to take the area of the field, and we're going to divide it by one person, which is now the 2.5 square feet. So we have 57,000 divided by, now instead of using the 4.2 from the experiment, we're going to use the rule of thumb of 2.5 and divide those two numbers, and we get 23,040 people. So now what we need to do is we need to ask ourselves, why are these two numbers different? Okay, what are some factors that could make, one of our estimate was close to 14,000 and the other estimate was 23,000. Those are two different numbers. So why is one more than the other? Well, the question is that who are these 24 people? He's a principal at what? A college or an elementary school? Did he use administrators? Did he get a bunch of football players that are already in their pads and try to pack them in? Are they social distancing? And so that's why we can only allow 13,000 people to fit on the football field, where this 2.5 is an average. So that may be why this number, the 23,000 number, is off, is because it's not including social distancing, or, he was looking at, are there students that are in wheelchairs or crutches so that they need more space in between? And that's the same thing going back up to the previous problem about these crowds. One of them, we had 45, almost 46,000, and then it went down when we used the average. So going back to the first problem, I used students, and 11 students could fit. But when you think about parades, like the Buford Parade, what are some of those factors that would make these numbers that we've estimated be wrong? And it's the fact that what are on sidewalks? There's light posts. There are sometimes benches or bushes. People bring strollers and chairs, and some even bring tailgate tents. So these estimations that we're coming up to, one could be off because we set up an experiment and we were using high school students, when you think about a parade, you're going to have a variety of aged people at it. So that's one reason that number could be off. And the second number could be off, again, because of things that are in the way, like benches and light posts. In the football field, what's out on a football field could also make these estimations change. There might be the bench or the field goal post that would take up a spot. So there are lots of factors that make these estimations not true answers. And again, it's going to be the size of people. You're going to have to think of what is in that area, like we said, with the lamps or benches, to really think about how you might need to change your answers for real world problems, or to find the real number of people that can fit in the area. So let me know if you have any questions. I hope this video helped.